much. Well, good afternoon, good morning, good evening, depending on where you may be. We'll talk a little bit about SD-Access and its evolution, and I'll give you my view on where I think it's evolving to, and share with you some of the details of the recent improvements and features that have been introduced into SD-Access. My name is Victor Moreno. I'm a distinguished engineer with the enterprise business entity within Cisco. We're the ones that actually build SD-Access. We also oversee all the integration with SD-WAN, and I'm particularly in charge of basically interactions between domains, so data centers, the campus, the WAN, etc. There's a series of protocols running underneath this. I've also been responsible for some of the definition of those protocols, so I'm deeply involved with this project. So hopefully I can answer all your questions. So we'll talk a little bit about SD-Access, where it's at and where we're taking it. And basically where we're taking it is we're giving you a distributed footprint of the access network, basically to cover your global enterprise and maybe beyond. How we integrate with the SD-WAN, how we integrate with the data centers. Those are going to be basically two key topics that we're going to cover, and that will basically cover the time that we have allocated for our conversation this afternoon. So you're probably well familiar with the whole message around this loop of expressing intent, driving it into the infrastructure, achieving levels of security that we couldn't achieve before, and then constantly reading and monitoring that infrastructure with telemetry ingestion and taking basically all that information and processing it. Sometimes in real time, sometimes we will basically provide suggestions on what to do in the network and keep that loop going so that that network is healthy, right? And when we first introduced SD-Access, that was probably one of the first instantiations of this outside of the data center. We've been doing some of this in the data center for a while with ACI. What we drove in SD-Access was the ability to combine wired with wireless, was the ability to provide mobility at rates that we couldn't address before. So the entropy that you find in the campus is much, much higher, ironically, than what you will find in data centers, just because people follow no pattern. There's nobody pushing a button there to move a VM. People basically come and go and move around, or you have robots in a plant where you're actually trying to follow these around. But in any case, mobility. And it became evident with the spread of malware that segmentation was going to be a key play for us to secure the network, and not just as we had done it in the data center, not how we had secured the data center from the rest of the network only at the perimeter, but also keeping infections from actually going from user to user, keeping me from basically airdropping my virus into your computer was basically one of the key things that we were after. So how we did segmentation in there was basically something we did at two levels. We did core segmentation, creating virtual networks with VRFs, and we provided mechanisms to automate that. And speaking of snowflakes, right, there's many ways that you could actually have implemented this. We chose what we thought was the optimal way, and we basically automated that. So you have a very efficient way of delivering segmentation in an automated manner. So where this is evolving to is it goes beyond just the one access site to cover a multitude of access sites. And you could think of an access site as anything from your main campus, ranging all the way to your smaller branches, right? And we want to have the policy that we've defined for the segmentation actually span across that entire infrastructure, end to end. Right? It's a little benefit to be able to segment in one pocket when you actually go to some other location and you're out of the segmentation security zone, right? So basically think of this as our evolution of the SD-Access from a single location to a multitude of locations to cover a global footprint. In doing that, we basically bring in the SD-WAN as an integrated component of SD-Access. So you will find that basically all our SD-WAN offerings are tightly integrated with SD-Access moving forward. So now we have a consistent view of the network, which we can actually manage through the same principles of defining policy, automating the implementation of that policy, and constantly having an assurance loop alive. But we can actually take those principles all the way from the axis of the network, regardless of where the axis would be, all the way into the data center. So we drop you basically at the footstep of the data center, and then I'll talk a little bit about what we're doing to basically have those data center networks interface with this access network that is fully segmented. Right, so that's the vision. The vision is that we can now create one network that interfaces with the second domain. So rather than having a multitude of smaller domains, we're going to look at this as one big domain. Okay. How many of you are familiar with SD-Access? Safe to assume most of the room. Okay, so just a very quick recap on what it is. Think of a network that is delivering overlay services and in a normalized way, basically giving you layer 2 and layer 3 services, as well as multicast, policy, etc., all basically following one single principle so that you're not creating snowflakes, and then having basically the management infrastructure that can give you all the policy-driven behavior, as well as the automation and the assurance that we require, right? So that's our management layer. That management layer is basically driving behavior in a network that has a few roles. So we have control plane nodes that are going to be the place where we maintain the state regarding who connects where. So your computer connects to the wireless network, and we're going to keep track that that wireless network is actually dropping you at this particular switch. And by knowing that, we can basically deliver the required policy to those ports. Again, another device connects somewhere else, and I keep a directory of basically what the locations and policies are for the different elements that are connecting to my network. Very different from a routing protocol. I'm simply maintaining a list of who is connected where, under which policy conditions, right? Now, this is one pocket of the network, and we have borders to that network so that whatever framing we're using within that fabric is terminated at those borders, and I now have a network-to-network interface that is going to allow me to communicate with traditional IP networks, with the internet, with your legacy network. And we have what we call edge nodes, and those edge nodes are basically where those devices connect, right? That's where I'm going to apply my policy. That's where I'm going to be able to recognize who is connecting to the network. And all we do is basically create tunnels amongst them based on the information that we have registered into the control plane. So there's some very efficient mechanisms in terms of how we support mobility when it happens here and how we update that control plane, plus the caches that we have here. We've reduced the state that is maintained in those nodes significantly. Only relevant flows are going to create state in all of these nodes. So how do we take this beyond a single site and take it to basically a multitude of sites? And when I say a multitude of sites, we're talking thousands, tens of thousands, right? The entire footprint of the enterprise. So basically, we've tagged this as the distributed campus. There's an internal joke at Cisco about, well, you called it multi-site, but multi-site in the data center means one thing if you're in ACI land, it means a different thing if you're in EVPN land, and it means yet a different thing in the case of a campus. So we refer to it as distributed campus, but you still see some references to multi-site as the architecture. In our case, it's under the control of a single management entity. But what we have here is those roles that we mentioned before, where we have a control plane, borders, and edge nodes, are basically present in each site. And the goal of doing such a thing is to actually give you independence from a fate sharing perspective in each site. Okay, so if my control plane goes bad on one site, or my borders start failing on one site, I lose my internet access on one of these sites, that doesn't affect the other site. One of the examples that led to the inception of this was basically the case where we had an emergency room in a hospital. So they liked the idea of the segmentation, etc., but they came back and they said, listen, the emergency room cannot have any shared fate with any other part of the hospital or the hospital system for that matter. That's a small footprint where we had to basically dedicate things. Now, if you think about it, this looks very much like what an OSPF network would look like. Area 0, areas 1, 2, 3. So it makes sense to structure things in this way. Autonomous system 65001, 2, 3, and some autonomous system in the transit, right? So it's not counterintuitive to structure things this way. Now, some of the benefit that you get is that not only do we have this structured in such a way that you get the independence from a fate sharing perspective, but you also get some interesting scale benefits. Because now one site only needs to have basically information about what's locally connected. So what I'm keeping in this control plane here is only what I have locally connected. Anything beyond what I have locally connected is going to be sent to the borders and basically opt into the transit to get to the other sites. Okay. Now, the difference between what I could do with OSPF with 3 areas and an area 0 in the middle and this is that now I can do mobility across the sites and still maintain that very nimble state. So what happens is the hosts get rehomed from one site to the next. And I maintain basically my scale controls. So as far as capacity planning goes, basically I'm planning for the state, both in the size of the caches on the switches at the edges, but as well as the size of the control plane capacity. Okay. In many cases, you won't need the mobility across the sites, but when you do, basically there are ways to engineer the control plane in the transit so that it can actually scale horizontally to whatever size you need to do such a thing, right? So we have some, in the transportation industry, we have some interesting use cases where you're actually seeing mobility across a multitude of sites, and the sites are actually regions, geographic regions. So the other thing that's interesting here is you can have independent services like internet access and things of that nature. So let's look at it in a little more detail. What happens is that we define what we call a fabric site. Right? And the fabric site is basically that independent entity. It has its own control plane. It has its own edges, its own borders. But it can also have its own wireless LAN controller. It can also have its own instance of an ICE PSN to actually enforce policy. It can have its own instance of DHCP servers, of DNS servers. It can be as independent as you wish to design it. Or it can share some of these services with other sites. In general, the bare minimum are the control plane and the borders are dedicated to the site. Okay. And you can have basically sites of different sizes. They align with the design portion of DNA Center where you're actually defining your geographic regions and your sites, but they can be as small as this room and they can be as large as an entire city or a country. Okay. All depends on how you want to design things. So for example, this would be an example of the ER in the hospital, just one floor. This could be an entire building that happens to be one site and it has to survive whatever everybody else does. You may have an entire campus that can be a site. In the case of Cisco, in our campus, we have these pockets, right? And engineering seems to align with those pockets. So we've got clusters of 3 or 4 buildings. And basically the design for the Cisco campus would be something like that. We'll have 3 or 4 buildings that are their own site, and another 3 or 4 buildings that are their own site. And no wonder building 10 is its own site. But you get the idea, right? Now, all of this is built so that we can get to the data center. Whether that data center is our own private data center or that data center is basically in the cloud, we're building this so that we can get to the data center. And I'm showing a logical representation of a site that could be thought of as an exchange site. But basically, we're extending the same policy models all the way in the segmentation, all the way to the footstep of the data center. And I can go into my private data center, and I'll show how we interface with ACI by putting basically an SDA-capable device right in front of my ACI border. Yep.
Victor, I've got a question.
Yes.
So on your slide, the green routers are control planes, and the red routers are border routers. Are the red routers actually the orange ones?
Yes.
Are those border routers just running Cisco iOS, or are they capable of doing this with some kind of SD-WAN like the one from Viptela?
So yes, they are
the answer is yes to both.
They are running iOS.
Okay.
They are running iOS, and the Viptela code eventually gets merged into iOS, and it's a matter of a quarter or two.
Okay, so this looks like a classic SD-WAN slide to me.
Yeah.
Okay.
Things are coming logically together.
Okay.
Yes,
just making sure.
Great insight. But yes, so these routers will eventually, and I'll walk you through the variations that take us there over time, right? They eventually become a single device that is running both the SD-WAN code and the SD access code, and they have basically one leg to each. That's where we get to. That's where we want to get to. We're not quite there yet. Yeah.
Maybe jumping the gun. Just tell me if I am, but to talk between locations.
Yes.
That requires some sort of way management device. If you were to talking your ER example where you have just one floor of a building that you want to be its own site.
Yes.
To talk with the rest, we need to have some sort of interaction that we would consider WAN in today's traditional sense.
At the border, it can be WAN. It can be metro as well. So you see this little cloud here, right? That could be a metro network, and I don't need to deploy a full-on SD-WAN solution there. I can basically use native.
Using a border router to talk to
You have a border router, but you have different areas, right? Or you have a fabric site, a transit area, and a fabric site, right? And you go through the borders, yes. I'll show you exactly after this slide. Where did it go? But basically, we will encapsulate from the edge to the border, do another lookup, encapsulate again, subject that to whatever policies you have there. If your policies are going to say for application A, follow service provider 1 or service provider 2, you will apply that there. You will encrypt if you want to encrypt, and then get to the remote border, and then do another lookup again.
And borders aren't shared. They can't be shared. The idea is we couldn't like nest or.
There's many variations of it, which we will walk over. Okay, but yes, they can be shared. Short term, they probably are not. Now, this whole thing is a fabric domain, and the fabric domain consists of fabric sites, and the fabric sites are connected by the transit. I think that's become obvious by now. There are two types of transits. There are transit areas that are native SD access, and they're basically using the same control plane and encapsulation that we use within the SD access sites. And there are transit domains that are what we call IP-based transit, and they basically are seen from an SD access border perspective as handing off the traffic to an IP network. Now, that could very well be in the form of a traditional WAN. It could be in the form of an MPLS set of circuits from a service provider, or they could be basically a Vitella network at that point.
Hey, Victor?
Yes.
I see up here in the corner this DNAC 1.2 and ICE. I'm assuming you're saying you have to be running this code to be able to use...
Correct.
Okay.
Yes. Thanks for calling that out. I do really bad with numbers, so I tend to ignore them, so thanks for bringing it up. And that was basically
I just thought up there and I was like, there's a reason that's there.
Yes.
It's not just
so
there for fun.
So that's the evolution. That's what's being introduced, right? So this was released very recently. I think 1.2 came out last week, and 1.8 has been there for not too long, but it's basically, this is our latest release. So when the transit is native, basically what you see is a fabric site with borders, edges, control plane. It's all controlled by DNA center, right? All the borders, all the edges, the control plane. And then you have basically a transit site that is running the same technology, and it has its own instance of the control plane. Okay? So as I go from left to right, I look up on the left control plane. I get my route to the destination. If it's not known locally, it means it's somewhere else. I go to the border. From that border, I do a second lookup. I go to the next border, and I iterate this way. I show one transit. You could have the concatenation of transits and different flavors of transits. All managed by DNA Center. It's a common policy end-to-end. What you see here at the bottom is basically a VXLAN header that contains the two sets of metadata that support our segmentation. We support microsegmentation based on groups, and for us to enforce it, we require the carrying in the data plane of group tags. So you can see how the group tag is basically maintained as we cut across all the domains. Nothing special to be done there. The other part that is important is the virtual network ID. And those are basically 24 bits that identify which VRF the traffic belongs to. So that's how we support macro segmentation and micro segmentation. So when it's native, right, to the question that was asked earlier, basically we can use the native technology, very simple to configure. The only thing that I need to specify is who do I want the control plane to be in the transit. Otherwise, all of these devices are known to DNA Center. They show in the inventory without me having to do anything special. I do not even need to specify which interfaces, physical interfaces, point in any direction. It's all abstracted for us to the point where I'm dealing with this at a very, very simplified level. Okay? So I can create a network and put a transit in between with very little effort. Now, the feature set that you will have here is the same feature set that in the transit is the same feature set that you would have in the SD axis. No more, no less. And that might not be sufficient for you to go over what could be a wide area network. In general, we recommend the use of this in the metro area, but it's basically all it needs is IP connectivity to get from one side to the other. Okay. The SD axis uses the Lisp control plane for the population of that database that we talked about, and we have basically the Lisp control plane at every stage. Okay, so this is the native transit. And we described this already. Basically, this is native transit, fabric site. Through transit to fabric site, we have end-cap and D-cap. Those solid lines with the dots are basically indicating a tunnel. The tunnel is terminated, do a new lookup. Terminate it again, do a new lookup. Okay, so I'm concatenating these tunnels. Now, I have, in most cases, a WAN that is already operational. It may be a service from a provider. It may be something that I've done with DMVPN or something else. God forbid, it may be something that it's not even provided by Cisco. But the model continues to apply. And the way we apply the model is basically my management is unified in terms of the segmentation end to end. What I'm going to do is within my sites, everything continues to operate the way it operates. I am normalizing operations to what we consider to be the least common denominator as far as network-to-network interfaces for segmented networks goes. This is basically inter-AS option A, which some of us refer affectionately as VRF Lite. So basically, we've put in two routers back to back with a bunch of VLANs in between, and we align VRFs to VLANs, and we run a routing protocol instance over each one of those VLANs, and you can now keep your VRF. So this gets you the continuity of the virtual network across. So you can see the yellow tag there in different frame formats basically contains the same set of information. It is strangled down from 24 bits to 12 bits here at the edge, but we have rarely found an enterprise that will exercise more than 4,000 VNs. Usually it's 5 or 6. So I think we have enough space there. Now, do these handoffs become a challenge in provider networks and when you're doing this as a service and being a multi-tenant hoster? Yes. But there's other ways of doing this. Now, what we're saying is for enterprises that are already doing things in the WAN, we can actually integrate with them and get you the experience of end-to-end segmentation. Now, the red tag is lost in that NNI, right? In that network-to-network interface, I'm losing the red tag. So what do? We basically transfer the information on which IP addresses belong to which tags out of band. Okay? So that means that there is a reclassification table at these borders. So when I get the traffic, I'm going to look at the source IP, and I'm going to impose the tag that SXP gave me. Okay? So I give it continuity so that I can apply the policies no matter where I go. Now, there's always a catch, right? There's a little bit of manual configuration that needs to occur, especially here. We have workflows for this. We don't necessarily for the border on the SDA side. For whoever we're peering with, you're going to have to basically set up a bunch of VRFs and the BGP instances that you have over the VLANs that go over the VRF Lite. Okay. And I believe the SXP was not automated either. So that SXP arrow that you see there, basically it's a couple of commands saying speak SXP with this guy. It's very gossipy. Anything it knows, it's going to communicate. And I believe SXP stands for Secure Exchange Protocol or something of that nature. You're probably more familiar with it than I intend to be. But then in IWAN 2.0, we have a similar type of handoff. Now, IWAN 2.0 has the characteristic that, or 2x, IWAN 2 has the characteristic of being able to carry the group tags. Okay, so we don't need the SXP bridge out of band. Same model, VRF Lite, but now in VRF Lite, I can include the group tags. And I don't lose any fidelity on the group tags. It's always 16 bits wherever you go. Basically, that's a layer 2 framing that I can use to actually carry group tags over that VRF Lite link. Okay, so what I've eliminated in the case of IWAN 2 is the need for me to actually have an SXP arch between the borders in one site and the borders in another site. So this is what I refer to as our IP option for the transit. Okay, so you can see it's very generic. Now, in comes Viptela. Right, so we buy Viptela, and now, well, guess what? Viptela doesn't support the group tag, so we need to give continuity to that. So we need the arch back in again, at least in the first instantiation of it. Okay, so this is fresh out of the box. We just purchased our Christmas gift. We paid 6 units of some sort for it, and now we have basically our new Christmas gift. You get it out of the package. Oh, no tags. Sorry. Okay, we do the same thing now, but we have an opportunity. We have APIs. So you can see how we can integrate the APIs so that at least the yellow portion of things are automated as we cut across these domains. Okay, so that's the foundation of the first stage in integration, is basically, okay, let's assume we don't carry these, and we're just going to do API integration so I can automate the creation of a virtual network. So now I go to DNA Center, and when I go to DNA Center, in the workflow where I create my VNs, I create my VNs once, and if I say that it goes across the domains, it will go across the domains, and it will trigger the creation of a VN to transport this in vManage. Okay? No rocket science there. The next step is, well, I can pass the SGTs here, and the WAN doesn't really need to do anything with the SGTs other than just transport it, right? So that's stop number 2 in the integration. Which takes us, once you have that integration of the data plane, well, if you change your interfaces, now it can be brought to one box. So now I carry my SGTs directly. And if you've looked under the hood of what Viptela does, they basically have an MPLS labeled stack. So you can foresee how we can add, any sort of stuff we want to put in that packet, we could add, potentially.
So it looks like to me that the end result of using Viptela to do this is the cleanest approach.
Yes.
So does that mean that you're not going to be putting much effort into doing this for whatever comes after IWAN 2.x?
Yes.
Okay, so the way forward is Viptela's SD-WAN.
That's where I went 3.0, yeah.
Okay, good answer.
Yeah. So, and you can see how we can basically have the API. I don't know why the arrow's not there. But so this is our direction, okay? I want to make very clear that this is where we want to go. This is where we're headed. Where we're at is probably the first slide I showed you with the Viptela separated by a VRF Lite wedge, okay? I should be more affectionate with VRF Lite because it does solve a lot of problems, but and I'll call it a wedge. But so now you've seen how we have these multiple domains, and basically what you saw in the last few slides is basically us creating those network-to-network interfaces between the data plane and the control plane. So we create that linkage, right? Now, the management and orchestration systems are either totally decoupled or loosely coupled, but they are independent. And they're independent for good reason, because they're doing different things. In the case of the WAN, we're looking at application recognition. We're looking at choosing paths based on application. We're doing all sorts of interesting things. In the case of the access, we are basically looking at integrating wired and wireless. We're managing stuff that doesn't pertain to the transport in that core and transit. So we have very independent systems. Same thing applies for the data center, right? The problem space in the data center bears little correlation to the problem space that we have in the campus and WAN. Okay, so expect those management orchestration tiers to remain independent, loosely coupled through API calls, right? So I can choose to basically drive behavior from one into the other. There is no real master. What we do look at in a land of equals is basically creating a single sheet of music that they can all read from, right? And that's our policy. That's how we translate our intent into something that everybody can read. And it's a very simplistic approach right now where we're basically defining groups of assets, either users, things, or applications. And our task is basically to define what the interaction is expected to be between those. Either we allow communication, we disallow communication. If we allow communication, how do we allow it? On which port numbers? Do we want to do application recognition to make sure that it is the right application? If the communication is allowed, should it be subject to certain checks? Depending on where I'm asking from, do I do different checks? So if I am trying to get in from overseas versus a local site, do I vary the path that I follow to get there? And if it's a different types of applications, do they go over different WAN links, right? So all of that is defined in my policy. That's my common sheet of music. So all of these domains would look at it and they will interpret it to the best of their abilities. Okay? So that's the view on how we get these guys together. So when you look at the integration here, you will see that there's some loose coupling between DNA Center and vManage. And then as it pertains to the data center, there isn't really any management coupling because we're not handling common devices. The interface to the data center we expect to be basically this VRF-Lite air-gapped handoff for the most part. Actually for all purposes, because what we don't want is this separate management system to be controlling a border and then this other management system to be trying to control the same border. So we want to keep those borders within the realm of their own management systems. Plus, we want to normalize this to not just be the private data center interface, but also be the interface into our cloud services, right? So what we do initially is we exchange identity information between those data centers sites and our domain. Okay, so now we've simplified this whole structure that had all these different moving parts to be one domain. And that domain, from a policy perspective, from that single sheet of music perspective, is actually communicating with the neighboring domain. Now, that neighboring domain is rich in itself. If you've heard about things like ACI Everywhere, what ACI Everywhere is doing, in a nutshell, is trying to normalize the interface and how you've modeled applications across all that variety of clouds and present it in a way that basically maps to our view of what an identity is or what a group is. Okay. So two halves to this, and we basically need to have them talk to each other. So in order for us to talk to each other, we're going to exchange identity. Eventually, we get to a point where we can exchange both identity and policy. So if you have defined policies in one domain, and I only showed the data center and the enterprise network because that's what Cisco controls, but the reality is there is a domain there that integrates in the same way that is a security domain. Right? And Cisco has an offering in the security domain as well, but it would complicate the graph to a point where it would be it wouldn't be a useful graph. But you get the idea. So all of these different domains could now basically exchange information. Say you went into your firewalling management system and you define your policies, and now you want to make sure that your networks that are now putting ACLs and whitelisting stuff are actually compliant with that so that they don't get in the way of that policy. Well, you can push that to a cross-domain bus. And that cross-domain bus is a read-write for everybody who's dealing with policy. So now I've effectively normalized it. Okay? Before getting to that point, everybody has their own policy domain. So the key is, for that to be effective, you need to have complete information. You need to know about the groups that you have locally and the groups that you have over in the data center. And vice versa. In the data center, you need to have the full picture so that you can then create all the rules that apply to user to application communication. So in a more graphical way, this is what I'm getting at. Basically, I have users. I've classified users here by all sorts of methods. I look at dual-factor authentication, their credentials, certificates on their devices, etc. And I combine all this stuff and I identify them as user group 1 or user group 2. Once I know that, I am going to communicate the results of all my hard work in the access to the data center guys. The data center guys, in turn, have knowledge that we will never aspire to have on the access side of the house. They know about all of these applications. Well, they're going to share that great knowledge with us. Okay? So now I have policy domain 1, policy domain 2. The connection still needs to go all the way from left to right. So these things better align. But the first step is give me enough information so that I can author the policy on either side. They're independent for now. So now, 2 independent policy domains that need to be orchestrated. Eventually, what we get to is that federated system where it's defined once. No conflict. Okay? There are ways to get there. It's not necessarily where we want it to be. There's a lot of development at Cisco to actually get to that point. One example of systems that are separated that way is you will see in Titration Analytics that we have ways of actually doing segmentation within the data center that is done on the host. It's not done on the infrastructure, right? Well, they understand all the grouping that we're talking about. They render this into IP ACLs, or they call it IP lists. Basically, the communication here is group A, and by the way, this is the list of IP addresses that belong to group A. So when he receives a packet from a particular IP address, he knows that it's from this group, and we can define policies consistently as groups, relationships between groups. Okay? Now, that same principle, and of course, I continue to enforce my user-to-user policies in the access network, right? So that continues to be critical. And what we will find is that there is some semblance of groups, no matter where you go in the data center space. If you go to Open Daylight, it looks very much like what we offer. If you look to ACI, of course, it's pretty much identical. If you go into Amazon, now it's a series of tags, and it's a little richer than just the flat structure of one group per endpoint. Now, when you start combining those tags with certain rules, you can actually distill that into a flat space of groups. And that's what we do with our tool for the cloud policy integration, where we have the cloud policy platform that allows us to basically write the conditions on how I combine those different tags to translate them into groups. What we're doing is basically normalizing all of these different clouds, assuming you're not using ACI Everywhere, right? But we're taking the tags that are being exposed on the APIs from the cloud, and we're distilling them into groups that we can manage, and we can continue to establish the policy just the way we do in the SD access. Okay, so that all gets distilled, it gets communicated to our identity services engine, and there we can now basically offer this to the ACI domain, offer this to the SD access domain, and apply policy. No matter where the workloads go, the policy is the same. And for that scenario where I have policy defined in one place, policy defined on another, I may want to use ICE or some of our partners, AlgoSec, Tufin, to actually make sure that there is consistency. Okay, so there's ways to instrument this today where we can actually start checking for that consistency of policy. One thing that I find interesting is that we will be applying policy within this domain. Usually when we go to the IaaS offerings, it's up to us to apply the policy there. So I would say that even a VPC that is leading into the applications is now part of our access network. From that diagram that we saw on left and right, that falls onto ours. So we put basically a CSR 1000B. You see demos up in the innovation cluster where you have basically an implementation of a footprint of SD access in a container. So you can put it right in front of your workload. But the key is that we're basically stretching that access network all the way to the foot of the data center. And then you could argue that, well, the policy is only being implemented on the left side. There's really no policy, user-to-access policy, being implemented on the right side of that. At which point, exchanging identity only is enough, because you only have one domain for policy. And that brings me to the footprint. So this is basically our network, and it looks very much like an SD-WAN diagram, right? So it's SDA in all sorts of flavors in different places, integrated with Meraki, integrated with the legacy campus, bringing us to the data center. Whether we access that data center through a physical colocation, or we take the footprint of our SDA into a VPC, or we build a traditional data center and create a DMZ and then from there branch off to the cloud, regardless of the model, you could model that as just a cloud edge. And it has 3 or 4 different ways of being instantiated. But the key is I'm bringing my segmentation all the way to this edge. And then in here, I have a full ecosystem of solutions to do things. But I showed you a couple of ways in which we bring things together and translate it to the same model. So you could choose to enforce your policy in a distributed manner. Basically, I have all my enforcement points at my internet access points or at my branches, at the borders. And now I have basically enforcement points at all the places where I can procure a footprint. Notice that SaaS tends to be the exception. So for direct internet access to SaaS, you're probably going to be enforcing all your policy with a zone-based firewall at the branches, right? Or some people choose to drive it all through a carrier-neutral facility where they scrub all this traffic in a centralized way. They put a big honking set of firewalls there and other measures, and then all of this has basically optimized links into the different cloud offerings. Right? The key is that whichever way you're getting to that data center, we're providing the segmentation end-to-end from the access all the way to that last enforcement point. Right? Because things can go wrong in transit, and we don't want infections to go between those containers. So once I've deemed you are allowed to access this application, well, you better be clean. You better not be exposed to risk, right? And that's basically me being 2 minutes over time. Brianna, that's a miracle. I'm usually like 10 minutes over time.
And then you have 5 to 7 minutes for some questioning.
Okay.
Questioning?
Go ahead. I am here for questioning.
I have some questions. I have a
Yes.
question.
Great.
Specifically I'm a bit skeptical about the policy translation.
Okay.
And when I say this, I understand when you talk about Cisco Enterprise, when it comes to SDA and then also SD-WAN, I'm sure you guys are going to work well together.
Yes.
Traditionally in Cisco, we've seen challenges working across BUs. So is the ACI and the data center business unit working with you guys to do this, or is this you guys independently trying to do translation in and out of ACI? Because I see
No.
3 different mechanisms. I see entities which you don't control, cloud, which
Yes.
you're trying to translate. You have
Correct.
different business units within Cisco, which you have to translate between, and then you have your own ecosystem on the enterprise side, which I have lots of hope there. Some hope for the data center. Cloud, we'll see.
So ironically, cloud is the easiest one.
Okay.
Because basically all we're doing is grabbing information that is basically publicly available from the cloud provider, right? So this is exposed in a public API, open API. We just grab it, and then we enforce policy wherever you can procure a footprint. We enforce the policy. So that integration is basically exercising APIs for the most part. Now, the tool that I showed you is a tool that basically allows you to basically take that information that is not structured in the way that we'd expect it and distill it into a structure that you can use so that you have one model in how you apply policy.
Sure.
So that one I'm confident that will succeed in.
Okay.
For the enterprise to data center interaction, one way to summarize it is I think we've got an increased budget for our bar tab so that the two groups can actually get together and discuss. So in all seriousness, we are working together very tightly. This has bubbled up to upper management as a priority, and basically it's been mandated from the top down that we actually do go to the bar and figure it out.
It's really important that you get this right.
We are working together. So what you've heard here is basically being done in collaboration with the INSBU team, and we meet regularly and eagerly.
Okay. Good.
And then within EN, there is always the challenge of prioritization of features, right? And the minute product management hears that we can have a workaround, then they're like, okay, so then I'll get other features in. So that's more of a, once the priorities fall in place, you will start seeing more and more results.
Okay.
So how are you guys choosing the priority of those features? Because, I mean, there's a lot of them, and so how are you cherry picking those essentially?
That I quit product management a few years back to avoid. It's basically business demand.
Okay.
Business demand, quarter by quarter, revenue, the street. Basically, it's printing money. That's basically what drives it. Of course, there's always a few slots there for making sure that we have the right direction and it continues to progress, right? So it progresses faster or slower depending on what the demand is.
So the key to all this right now is the DNA center. And DNA center is not necessarily approachable for a variety of reasons to customers that are not very large. So is there a point when that's expected to scale down to be more approachable for smaller customers?
Yeah, more affordable DNA center. There's a lot of discussions going on in terms of how we can actually trim down the footprint of DNA center. And the key thing that is driving the large footprint in DNA center is assurance. So we have a confluence of the automation and the assurance functions on the same set of servers. Now, if you think about it, some of the ideas that are being tossed around is you have a relatively large footprint in the network, and all of those network devices have either 4 or 6 cores. The appliance that we're looking at in DNA Center right now is basically 114 cores, right? It doesn't take much to get to 120 cores of processing distributed in the network. So those are some of the things that are being considered. That cost is already built into your network. And yes, you will continue to have appliances, but there will be much lighter appliances. You could potentially get to a point where you have virtual machines actually running this. That's very far out though, right? But there is an intent. There is a desire to actually get to that because we're seeing the pressure back, right? Yeah. Because the costs aren't necessarily aligning. Yeah.
Thank you.
So with everything headed that way very, very, very quickly, what's going to fill the gap? There are only 500 Fortune 500 companies.
You did the math.
That was quick, too.
Mind
We got me thinking.
Where's the rest of the market going to go when everything is DNA center driven and
Meraki.
it's leaving behind a massive chunk of customers.
And and we can't act fast enough on that, basically providing the options. I talked to you about the most futuristic option that I have in my mind right now. Realistically, the group is looking at off-cloud offerings. They're looking at separating assurance from automation, so you can offer automation as a single package in a smaller footprint.
Well, I mean,
those are the type of things that.
So I see what DNA Center is and where it is, but that's big companies. The smaller companies, small universities, stuff like that. What's going to happen to those customers that don't want automation, don't want assurance, just want management? Where prime infrastructure is sitting now, and everyone sees the writing on the wall there. What's going to happen to those people that just want config management and templates?
Yes. The functionality continues to be offered, right, through DNA Center. The question is the footprint and the form factor that we need to deliver for that kind of customers.